At sunrise, a major airport can launch hundreds of flights in just a few hours, and each wide body jet may need tens of thousands of gallons of fuel before it moves. Passengers see gates, runways, and control towers. Hidden beneath that routine is a fuel system built to feed aircraft nonstop, because one broken link could stall an entire airport. Every flight begins as a fuel calculation long before the aircraft reaches the gate. Airlines know the aircraft type, the route, the expected passenger load, the cargo weight, the weather, and the legal reserve fuel required if the plane must divert or circle before landing. A small regional jet flying a short hop may take on only a few thousand gallons. A wide-body aircraft crossing an ocean may need more fuel than several highway tankers can carry. Add stronger headwinds, extra cargo, or a distant alternate airport, and the number changes again. Now picture the scale. A car might burn a few gallons in a day. A delivery truck might use dozens. One long-haul airliner can load tens of thousands of gallons before a single departure. A busy airport can send out enough aircraft in one day to consume millions of gallons. This is why airport fuel demand is not guessed. It is scheduled, forecast, measured, and constantly adjusted. At that scale, fuel stops being a product delivered by a truck. It becomes a city-scale utility. Jet fuel begins as crude oil, refined into a tightly controlled petroleum product called aviation turbine fuel. From the refinery, it enters a distribution network that may include pipelines, coastal tankers, inland barges, rail cars, or highway tanker trucks, depending on where the airport sits. For the biggest airports, the most important link is often a pipeline or a nearby fuel terminal. Fuel can move in large batches from refineries or import terminals into regional storage, then directly toward the airport without relying on thousands of truck trips. Smaller airports usually do not have that kind of connection, so tanker trucks make more of the final delivery. On screen, the flow is simple: refinery or import terminal to regional pipeline or depot to airport fuel farm to aircraft. Each arrow represents contracts, testing, scheduling, and transport capacity arranged long before the passenger ever reaches security. But getting fuel to the airport is only step one. Once it arrives, the airport has to hold huge volumes safely, keep water and contamination out, and make sure the right fuel reaches the right aircraft at the right time. The fuel farm is where the airport turns deliveries into a usable reserve. It is usually set away from terminals and public roads, with rows of large storage tanks surrounded by containment berms, access roads, pipe racks, pumps, filters, valves, gauges, and control equipment. These tanks are not just giant barrels. They are built so crews can inspect them, drain water from low points, sample fuel, control temperature effects, and move fuel at a steady rate without stirring up sediment. Fire protection systems, grounding connections, and spill containment are part of the design from the start. Airport fuel storage is also planned around time. A busy airport cannot depend on a delivery arriving at the exact moment the next wave of aircraft needs fuel. Operators keep operating reserves, so normal delays, peak traffic, pipeline scheduling, or truck timing do not immediately threaten departures. On screen, this hidden system looks simple: tank level gauges, safety berms, color-coded pipes, and a storage graphic filling and draining through the day. But every gallon is being held under controlled conditions before it ever reaches a wing. From the fuel farm, the next job is getting fuel across the airport without slowing down the turnaround. At smaller airports and at remote stands or cargo ramps, the most visible answer is the refueling truck. Some trucks are tankers, carrying jet fuel inside their own tank and pumping it directly into the aircraft. They are mobile fuel stations, useful where aircraft park far from fixed pipes or where traffic does not justify a buried network. At larger airports, many vehicles that look like fuel trucks are actually dispensers. They may not carry much fuel at all. Instead, they connect to a hydrant pit in the pavement, draw fuel from underground pipes, filter and meter it, then send it through hoses into the wing. All of this happens during the aircraft turnaround. Passengers board, bags move through belt loaders, catering trucks lift to the doors, ground power runs, and fuel crews work inside the same narrow window. The system has to be fast, measured, and positioned so vehicles do not block each other. So why do the biggest airports bury part of this system underground? At a major airport, the ramp is too crowded for every aircraft to be served by a fully loaded fuel tanker. So the airport moves the fuel network below the pavement. From the fuel farm, underground pipelines run out toward the terminals and aircraft stands. Near each parking position, the pipe connects to a hydrant pit, a small access point built into the concrete. To a passenger looking out the window, it may look like an ordinary cover in the ground. To the fuel refueling crew, it is the aircraft's fuel connection to the entire airport. A hydrant dispenser pulls up with hoses, filters, meters, and pumps, but little or no fuel stored on board. The crew connects one hose to the hydrant pit, another to the aircraft, and fuel flows from the buried pipeline into the wing tanks. This removes the need to drive thousands of gallons across busy ramp lanes for every flight. Turnarounds become faster, vehicle traffic drops, and the fuel operation stays tied to fixed, controlled points on the stand. In an animation, the airport would look like a hidden circulatory system, fuel leaving the farm, branching beneath taxiways and aprons, then rising at each gate exactly where the aircraft needs it. Avoiding a fuel shortage starts weeks before the aircraft arrives. Airlines send flight schedules, expected aircraft types, and planned fuel loads. Fuel suppliers compare that demand with refinery output, pipeline capacity, storage levels, and truck or barge availability. Airport operators coordinate the access, safety rules, and timing so deliveries do not collide with ramp operations. The forecast is not just a normal day multiplied by the number of flights. Holiday travel can push more departures into the same hours. Long-haul flights may need far heavier fuel loads than short domestic routes. Cargo peaks can add large aircraft overnight. Weather can force diversions, holding patterns, or last-minute route changes, all of which increase fuel burn and demand at airports that were not expecting those aircraft. Inside the fuel farm, tank levels are measured constantly. Operators track how much fuel is available, how fast it is being issued, and when the next delivery must arrive. New shipments are scheduled before reserves get close to critical levels, and major airports may have backup options through other terminals, pipelines, trucks, or nearby storage. The system is built to absorb surprises, but it is not magic. A refinery outage, pipeline failure, severe storm, or sudden wave of diversions can still strain it. When the fuel chain is disrupted, the first response is not panic, it is control. If a storm delays tanker trucks or a pipeline segment is shut down, the airport and fuel suppliers start rationing capacity before tanks run low. Airlines may be told to reduce uplift, meaning each aircraft takes only the fuel it needs for that flight plus required reserves. Long-haul departures, emergency services, and tightly scheduled connections may be prioritized over aircraft that can wait. Suppliers can also reroute fuel from alternate terminals, increase truck deliveries, or pull from nearby storage. In some cases, airlines ask inbound aircraft to tanker fuel, carrying extra from another airport so they need less after landing. These choices create delays, longer planning calls, and higher costs, not an instant shutdown. Ramp crews keep fueling, dispatchers recalculate loads, and control rooms compare tank levels against the next wave of departures. That is why passengers often never see the disruption directly. The fuel system is designed to absorb stress in the pipeline, the fuel farm, and the operations center before it reaches the gate. From refinery to pipeline, fuel farm, storage tank, underground hydrant, crew, and wing, every gallon is planned. Airports rely on forecasting, reserves, infrastructure, and coordination. Thanks for watching. Comment what hidden airport system we should explore next.